All right, let's take a look at page 37 in your book. We're going to talk about the properties of matter now, specifically physical and chemical properties. Physical properties can be measured or observed without a chemical change. There's a couple key words here: measured, observed. Those are some key words: measured or observed, and that there is no chemical change here. So basically, whenever you measure or observe a physical property, the substance keeps its identity. The substance keeps its identity. So some examples of physical properties. Things you can measure or observe without changing what your thing is. Luster. That's a fancy word that basically means that something is shiny. Shininess. Density is another one. You can measure density without changing what your thing is made out of. Solubility, meaning does it dissolve? That's a physical property. Other things, measurements like mass or length, color, and temperatures. Those are all some examples. There are lots of other physical properties. These are just a few examples. Chemical properties. These are properties that if you test the property, it requires a chemical change. If you're going to even see if it has a property, there will be a chemical change. The substance will change its identity just to test the property at all. The substance changes identity when you test it. So, some examples: the ability of a substance to burn or ignite, causing fire or combustion. That is combustibility. Or flammability. The ability of a substance to chemically react with other substances. That is reactivity. Both of these, if you are able to show something's flammable, then that means you have been burning it, and burning it's a chemical change, which means whatever you started with has changed into something else. It's got a new identity now. Just by proving it was flammable, you've caused a chemical change. That's what makes flammability a chemical property. Same idea with reactivity. If you prove something's reactive, well, then it has already reacted. It's undergone a chemical change, and you have something different than what you started with. That's why reactivity is a chemical property. The ability of a substance like a toxin or poison to harm humans or animals. That's called toxicity. Again, if you notice that something has poisoned you, then the only way for that to have happened would be if it got into your cells and started changing things around by reacting with stuff inside your cells. It caused chemical changes. That means observing that it was toxic means you observed a chemical property. And finally, the separation of a substance into simpler substances, often due to heat, light, or chemical biological activity. That is decomposition. And again, if you observe something decomposing, you are observing it changing into simpler substances. And when it's changing into different substances, that means you are seeing a chemical change, and observing that chemical change means that decomposition is a chemical property. Let's try some problems together. It says, classify the following as chemical or physical properties. Explain your reasoning with complete sentences. Water has a density of 1.0 gram per cubic centimeter. Note, density is determined using mass divided by volume. Will the identity of the substance change if we observe its density? If you take a mass divided by a volume and measure its density, are you changing water into something else? No. Which means that this is a physical property. When we explain it, it needs to be in complete sentences. This is a physical property because observing it does not change the identity of the substance. This property may be observed using, and there's a couple different things you could write here. Measurement is probably the most obvious. Number 2, the flash point of alcohol is 79 degrees Fahrenheit, and then it says, note, flash point is the temperature a substance will combust, meaning the temperature will become flammable. Will the identity of the substance change if observed? If I observe that its flash point is 79%, I'm observing it combusting at 79 degrees. I said percent, I meant degrees. At 79 degrees, I'm observing it combust. When it combusts, it's going to burn, and that is a chemical change. So will its identity change? Yes. That means that observing this flammability is observing a chemical property. My explanation needs to be a complete sentence. This is a chemical property because observing it does change the identity of the substance. Testing this property would result in blank, which is a sign of blank. It would result in combustion, or you could say burning, which is a sign of flammability. When you're done writing that, I want you to skip ahead a tiny bit to page 39. We're going to come back to page 38 later, but we're going to skip ahead to page 39. Page 39 is about intensive and extensive properties. So physical and chemical properties, that's something you should know from middle school. Intensive, extensive might be new to you. It probably is new to you. Intensive properties are independent of the amount of substance that you have. Intensive is independent, so that's kind of like a memory trick here. Intensive is independent. They both start with in. That helps you remember they go together. Okay, and what that means, independent of the amount of substance, that means the amount of stuff does not matter. That's what that means. The amount of stuff does not matter. So these properties sorry, I got distracted. These properties cannot be added together. For instance, if I want to look at something and observe an intensive property, I'm going to observe something that is not based on how much of the thing I have. So, for instance, if I'm looking at this pair of scissors, this handle on the scissors is purple, and it doesn't matter how much of the handle there is, the handle is still going to be purple. So even if I took a tiny little piece of the plastic, or if I look at the entirety of the plastic, it's still going to be purple no matter what. Color is an intensive property because it does not depend on how much stuff I have. Also, it cannot be added together. It doesn't really mean anything to say, well, purple plus purple. That doesn't really mean anything. It cannot be added together. Temperature is another intensive property, where it doesn't matter like how much of a thing I have. its temperature is still going to be the same. And it also doesn't make sense to add temperatures together. If I have 3 samples of, you know, macaroni and cheese, and I take all of their temperatures, then saying like sample 1's temperature plus sample 2's temperature plus sample 3's temperature, that doesn't tell me anything meaningful about the macaroni and cheese. Because those 3 temperatures are separate from each other and would be the same regardless of how much macaroni and cheese I had. Another intensive property is density. That's actually probably the most important one for you to know, density. Where water, for instance, has a density of 1 gram per milliliter, and that doesn't matter how much water I have, whether I have 1 drop of water or an ocean full, that density is going to be the same. It also doesn't make any sense to add densities together. That doesn't tell me anything about like a total density if I try to add some together. Extensive properties are not dependent on the amount of substance you have. The amount of stuff does matter. And these properties can be added together. Most common examples are like length, mass, and volume. The length of something is going to change based on how much of it I have. If I have, for instance, a sticky note, I could take a ruler and measure the length of it, but that length is going to be different if I have the entire sticky note or if I have just part of one. I'm going to get different lengths when I have a different amount. Same with mass. I could take the mass of the entire sticky note by putting it on a scale, but I'm going to get a different mass if I take just part of the sticky note. And again, the same with volume. How much space it takes up is different if I have the entire sticky note versus just part of the sticky note. You can add those together. If I have the length of my first half and the length of my second half, I can add that together and get a total length, and that is something that makes sense. Same with mass. If I take the mass of this piece and the mass of this piece, I can add that together to get a total mass, and it makes sense. Volume also works the same way. Okay, at this time, go to your stamp page, and here is what my plan is. Miss Woodlock may change it depending on how much time is left in class right now, but on your stamp page, today, depending on if it's an A day or a B day, is either the 30th or the 31st. My plan is for you to get a stamp for finishing the practice problems that are on page 38 and also doing the activity at the bottom of page 39. Now, if Miss Woodlock does not think there's enough time, she might cut this down. So listen to what she says. But at this time, my thought is for you to both finish page 38, and again, make sure that your explanations are in complete sentences on page 38, or you're not going to get your full 4-point stamp. And there is an activity on the rest of page 39 as well. Again, Miss Woodlock may change that depending on what time it is and how much time you have left in class, because there is one other video you still have to watch today before class ends. And, oh, you know what, actually, page 47 is supposed to be on here too. That'll be something you can't do till after the second video that you're going to watch today. Again, Miss Woodlock may change this. You do still have another video to watch. She may decide there's not enough time in class for you to do that activity on page 39. So listen to her, and I'm going to end this video, pass it off to her, and she'll decide if you have time for that activity or if you're going to move straight into the next video.